Hi out there in TV land, we're going to do some demonstrations for you relating to radiation. So first of all, I'm going to show you this. This is a temperature probe. I'm just going to start this off and we're going to see here roughly what the temperature in the room is. So hopefully it's bringing in points here. I'll just bring it so we can see it a little easier. So I'll bring it down like that. Bits. I'm just spacing out a little bit. You can see roughly the temperature is around 24 degrees. Okay? Roughly. Anyway, this here, what you won't be able to see, is a radiant heater. So I'm going to show you how the temperature goes up. We're going to go onto the graph in a moment and you'll see. So at the moment it's just lowering to temperature. It's very sensitive, but you'll see as soon as I put it over the heater, which is over here, it will go up quite suddenly. So there we go, I'm not even that close to it. You can see it's going through the roof there. Now if I take it away again, it should cool down fairly rapidly. So we'll see that in a moment if I move this out of the way. There we go. Well, it's certainly not increasing in temperature. Okay, so I'll bring that down onto the screen. Now what I wanted to show you was that this is not anything to do with convection and conduction by using two things. I've got this book and I've got this piece of glass here. So the book is not transparent, but the glass is transparent. So I'm going to put the book over the top of our radiant heater and then I'm going to put the temperature probe over the top and we'll see the temperature will rise slightly because that's a very hot heater, but not very much. So let's see. If we look at the graph there now as well, it is going up, but not very much. That tells us there's a little bit of heat coming out, but not very much. So I'm going to take that away now. And now I'm going to get the glass. So both glass and paper are not very good conductors. So I'm going to put the glass over the top now and we'll watch what happens to the temperature probe this time. And if you look, you can see it's rising quite rapidly. So that's telling me that some heat is passing through by radiation. That's probably because it's transparent. You just stop this phone. Okay, so there we go. It's still going up at the moment, so it's touching the glass and the glass is warm. So there we go. So what I was trying to show you there was that radiation will pass through glass because infrared, which is the, as you know by now, is the kind of radiation that we are talking about. Infrared waves will pass through glass, but they won't pass through paper. They're both insulators. It's about rays and waves. Okay. If I just hold it over the top like this now, it goes up suddenly because I'm also measuring the temperature of the convection currents, the hot air that's rising. Okay. So that's rising a lot. With the glass there, it will rise just a bit. But that heat is coming not from convection, but from radiation. And we can see that just about. Okay, so we can stop there for a minute. Okay, so we're going to show you a famous experiment, and this experiment is to do with conductors of heat. So I've got two metal containers that are equal in size, they're made of the same substance. They've got the same amount of water in them. And the water is cold at the moment, so we're just reading the temperatures there, and we can read off that one is roughly, is that 24, I think? And the other one is pretty much 24, so they are at the same temperature. So hopefully you can see, and probably at Key Stage 3 at some point, hopefully you've studied a little bit on radiation, and you should know something about this matte black surface and this silver surface here. So what we're going to do is to put the radiant heater underneath and see, and then come back in a few minutes and we're going to see which one's temperature has raised the most. So at this point you can pause the video and write down a prediction of which one you think will get hotter. So we're going to come back in 30 minutes time and see which one is hotter. So you could write down your prediction now.
There you go.
Okay, so we're back. We're going to take a quick look at our results. So we left this for a bit more than 30 minutes actually, so let's come and have a look at the thermometers. Here's the matte black one and here's the silver one. If we take a look at the matte black one here, which is this thermometer, it's very nearly 75 degrees, and the silver one is just about 52 degrees. So what does that tell us about the absorbing ability of those colours? Because in every other way they are the same. So which colour absorbs the most? I think the results are fairly clear. So can you at least put down a sentence to show which of the colours absorbs the best? Okay, so we're back with a really similar experiment now. This one is not about absorbing heat. Last time we had a heater and we were seeing how the colours absorbed heat. This time we have hot water inside these already. They're completely full, and we are measuring to see how well they emit heat. So emit heat means give heat out. So instead of absorbing, take heat in. So we are starting with a very similar temperature, and we're going to find out which one radiates heat better, emits heat better. And we'll know this because when we come back, we'll find out which one has cooled down the fastest. If it has cooled down faster, it has emitted heat better. So good emitters cool down quickly. So this time we better have a look and make sure that we've got similar temperatures at the beginning. It's quite hot water from the kettle. I'm looking at this one here, and it's reading 65, roughly. The focus will come in. It's trying. Maybe if I put my hand back there, there we go. And this one over here, they were at the same temperature out of the kettle. This one's around 69. So they're not quite the same temperature, but they did go in from the same kettle. So we're going to come back in a few minutes and see if the difference is more on one than the other. Okay? And the one with the biggest difference will be the best emitter of heat. So we're going to come back in a few minutes. Okay, so we're just going to check in now, and we think that's enough time to really make a difference. So we're going to check the temperatures, and right here, I'm looking around the back here, I'd say that's 55 degrees. And let's check the other one, that is 60 degrees. So clearly, this one is 5 degrees cooler, that's significantly different. That means this one is in fact emitting faster than that one. So not only does black absorb heat faster, it also emits heat faster. That means that black things heat up faster, but they also cool down faster. And people don't tend to realise that. The misconception that we see from tourist students is that they heat up faster and they remain hotter for longer, but that's not true. The truth is they heat up faster and black cools down faster. So if you take one thing away, take that please. Okay? Take care.